This is probably my most favorite section in Calc 1. It's on applied problems. And rather than start with the one I was going, let's get some instructions first. So these are like basically optimization problems. Finding the max or min.
This people. Fine.
Yes, 4.5, thank you.
Jones,
Yeah,
is the syllabus date still messed up since we took the test later, or since we're on like 4 point,
no, because the dates were just swapped last week.
so.
Yeah, we are on the right schedule. Finding the max and min. Alright, so some basic guidelines, read the problem. Well. Maybe slowly. A couple times if necessary. Make sure you know what it's asking. Understand what it is. What info is given? What is the unknown quantity you're trying to find? Draw a picture. Label anything that's important to the problem. If it's something that's changing. Give it a variable. Even if they give you a value. We saw this on the test with the baseball problem, baseball diamond problem. Home plate to first base was not changing, but you need to give it value, and one of the other parts. Was changing and people were not giving it a variable. Even though like the 10-foot part, they weren't giving it a variable, even though. It was changing, with you're running to second base. Alright, so now that we've got a picture and we've got some variables for what's kind of going on. List every relation. You can think of in picture. That might be helpful. In finding what you need. Finding the unknown quantity. These are quite often formulas or algebraic expressions. And identify the unknown quantity in terms of this stuff. So, oh wow, it's just coming apart on it, okay. So write the equation. Or an equation for for the unknown quantity. You might be able to get it down to a single equation with one unknown. That's the ideal, the optimal one, because your one unknown is what you're looking for. But you might end up having two equations or more, but usually two equations. With two unknowns. And the name of that step or the description of that step sounds easy. This might require considerable manipulation. Algebraically. Doing this is gonna get us some critical points, at least one, if not more. Test the critical point. And endpoints. Of the domain. If we're looking for a max or a min, we don't care if it's in the middle or at the edges, we want the max.
So it could be -5 to 5 or negative infinity to infinity, 1 to 10.
Yeah. Use what you know about the derivatives to help identify maxes or mins. Each. Who here plays Minecraft? We're starting with your example from Saturday.
I used to.
What was the question? How did they, what was it going on with it?
So they're trying to build a fenced area behind a house. That is using only 20 fences, 20 live long
Okay.
fences.
Well, the fence area behind the house. Behind a house in Minecraft. Using 20 fence units. And they wanted to maximize the area.
Maximize the area.
So if you don't play Minecraft, and I don't, I had to ask this. There's, you can't have a partial fence as an answer. The answer needs to be in whole fence units. No. Decimal part of a fence. Alright, so we have a house. House. I don't know if it's a rectangular house, but I'm making it a rectangular house. I assume the wall on one side is flat where we're putting this. This pen, basically. I don't know. Does Minecraft have animals in it and shit? Like you can put like farm animals, okay. And so they want to build a fence. Around part of the wall that maybe uses part of the house as part of the boundary. And so we want to max area here. So, I don't know, it could be like. It could be a long fence, like that. It could be like that, I don't know what's going on. So since the size of the pen can change, maybe let's label them. Those are just examples, I'm gonna call this the width. Cause we're making a box, so I'll call that the width as well, they should be presumably the same length if we're making it rectangular. And maybe I'll call this side L for length. Alright, so now we're looking for any relations that we should. Try to get here. One of them would be maybe the perimeter. The perimeter of the fence or perimeter of pin. A full rectangle would be 2 times the length and 2 times the width, but we don't have that here. We have one W and 2 Ws. 2 Ws and 1 L. And that total perimeter should be 20. And that's what I meant by if it's gotta give you a value already, but you're still looking for. It's something that's changing, there's changing elements, put both in there. The perimeter is 20, but it does have changing elements in terms of length and width. What are we trying to find here? We want to maximize the area, so we're gonna need the area as well. It's the area of a rectangle. Length times width. So the area is changing depending on what length and width we choose. Now, with it being whole fence units, we could literally go through and test each possible combination until we get a value. But this is a calculus class, we're gonna do some calculus. I've got two equations, I want an answer in terms of area, how the area is maximized. So like, we're gonna have some function and presumably. When we're done, we'll have some type of, like, if we graphed it. Something that's looking like this, and we're looking for a max area here. Which means we're gonna need to take the derivative area to do it. I've got two variables here, I don't want that. I don't wanna deal with two variables, so what we're gonna do is we're gonna. Solve for one of the letters in perimeter and plug it in here. I think the easiest one to solve for is L. By just subtracting 2W. If you wanted to do W, you could, but then you could have it divide by 1/2 and have a 1/2 in there. But that's gonna make my area equation. 20 minus 2W times W. So if I multiply that out. I have 20W minus 2W squared. What shape is this equation?
Square, right? Or,
Well, but it's got other elements, so it's not making a rectangle.
Right,
It's making a parabola, and what's the -2 coefficient telling?
downwards.
It's going downwards, right? The parabola is going downwards, which means we should have a max, so. What we got for our equation does match with the idea of having a max. How can I find the max?
Take the derivative of this equation.
So we're gonna take the derivative of this equation, the only variable we have present right now is width. So let's take DDW of both sides. When you do take the derivative like this, put the D over D whatever in front. Don't put it at the end, I saw that on several tests. People having DDW over here, and that doesn't mean anything, it's more of something that goes in front that is applied to what follows. So I have A prime or DADW. The derivative of 20W is 20. The derivative of -2W squared is -4W. How can I use that to find the max? We wanna find the critical points, what? Set it equal to 0, let's set it equal to 0. That'll help. That'll help us find critical points. I'm gonna add 4W to both sides. That way I don't have any negatives in there. And then we'll divide by 4 on both sides, and I get W equals 5. I don't know, units? I don't know if it was in feet or meters, I don't know what metric or system,
It's
if it even uses one.
it's cubes. It just says cubes.
It just says cube. So is the fence a cube?
Yeah,
So
it's
is that
weird.
some big thickness?
It's where it uses box holes, so it uses box holes to determine the length of everything, so it's a single cube, yeah.
So it occupies one space no matter what it is.
It's more like
You
a
can't really-
wall, okay.
It's just, it takes up space.
I don't know how Minecraft is so popular with the big old chunky things in today's age. Like you VR game, you can immerse yourself into a game that feels fairly realistic. And yet Minecraft with fucking block characters is so fucking popular and it blows my mind. Graphics are so shitty. I've got one of the one of the pieces of information, the width, what else do I need here? Length. And I can get that if I plug that in up there. L equals 20 minus 2W equals 20 minus 2 times 5, which is 10 units. So that should maximize the area. Length equals 10 units. Width equals 5 units. We can check real quick. What are my other options here? Cause I didn't check the other endpoint, I didn't check endpoints here. I could have a width of 0. So if I had W equals 0. Well, my area is gonna have a 0, so that's definitely out. And the other thing I could do, width could be a maximum of 10. Cause there's 2 widths. These are like the endpoints on this. W equals 10 makes L equals 0, and again, we have area equals 0. So. That is definitely the max. If you want to see it in action, what is the area for this? 10 times 5 is 50 units squared. And if I shifted it. If I lowered the width by 1, if I made the width 4. That would make the length 20 minus 8, which would be 12. And this would give me an area of 48, 4 times 12. If I went the other way and upped it an increment. W equals 6, well, the length would have to be 20 minus 2 times 6, or 8, and again, we have an area of 48. So 50 is the maximum area. And the information to make that happen was this. If you don't play video games or Minecraft, that's not helpful for you, but it is an example that some of you in here might appreciate. Let's go on to some other, like, more realistic examples.
Jones. That diagram.
Oh, yeah, it's the circle, right?
Yeah.
Hold on, let's do it at
Okay.
break.
I didn't wanna forget, so figured just say something else.
Anyone did it longer? So we can do an open top box. Is to be made. By cutting. Small. Congruent squares. And I'll explain what that means in a second. From the corners. Of a. 12-inch by 12-inch. Sheet of tin. And binding up the sides. What size squares should be cut? From the corners. To make the box. Fold as much as possible. Okay, so congruent. Spell it right. In this context is another word for identical. Congruent shapes have the same shape, same dimensions. They can be rotated, but like rotate like. This. And let's see if I can make it the same. Assuming this is S and S and this is S and S, those are congruent squares. Even if they are rotated. So rotation doesn't matter, but they just need to have the same size. So, what we have is we have a piece of tin. And it's starting out as a square, and we want to cut out corners from this. So it's getting cut out. And then what you could do is this makes little edges here. Where we fold this up. So fold the sides up. To make the box. Can you guys picture that? The one's struggling picturing that, because if you are, I didn't bring something I can cut out the corners, but I can show you like folding it up. Kind of doing something like this, bring up the sides. And then you're bringing up these sides as well, but since without the corners cut, you can't do it. So, but when the corners are cut, you can bring them up and make sides that meld together. And we know the entire length here is 12 inches. And we know this entire thing here is 12 inches as well. If we're wanting to cut out a square from each side, from each corner. And we don't know what size the square is, we're gonna have to give it a variable for the length of the side. If you wanna use X, you can, but it's a square, I'm gonna use S. Okay, so that's my picture. That's what's going on, those are gonna get removed. What am I trying to find here?
What's the maximum area you have? With, or can be
Not
held,
necessarily area. Volume. We're looking to maximize the volume. And volume of a box is length times width times height. So I could call this portion here. L. This portion here W. And the sides that are coming up, this is what's coming up, the height is these parts.
For the height, are you referring to the top of those small squares or?
That distance right there. Cause when we fold it up, that's gonna be the height of the box. So it looks like H equals S. Hopefully, we can write length and width in terms of S. Can we do that? If we can, then we've got something, the volume is all in terms of S. That's gonna make this a whole lot easier.
Like minus 2s.
We would length could be the whole thing minus 2s, right? This is like the whole thing is 12. And we're subtracting out, we're minusing that s and we're minusing that s. Yeah, we can subtract 2s. Looks like that's kind of like what's going on with width as well. And since it was 12 by 12, it's still gonna be 12 minus 2s. This might be a little bit easier if I factor out a 2. And let's put that all together in an equation for volume. I've got a 2 and a 2, so 2 squared. I know that's 4, but I want you guys to see where it's coming from. And we have a 6 minus s squared, because there's 2 of those. And then the height is s. Now, normally. I would say multiply this all out. So that you just get a polynomial, because it's easier to take the derivative of. But after seeing some of the atrocious. Is that the word? That sounds right. Atrocious derivative work I saw. We're gonna leave it as it is so we can practice chain rule and shit. But it's much quicker if you actually multiply it all out, but to make sure everyone's like on the same shit. We're gonna take the derivative of both sides with respect to s. Maybe I'll write this, I'll clean it up a little bit first. 2 squared is 4, and I'll put that s at the end with it. And then 6 minus s squared. So if we do DDS on both sides. We're gonna have dBds. I have a product here. Do not treat 4 times s as a product. That's just making you guys take the long way down there. I saw that on several things, people doing like a product rule on 4S. Absolutely ridiculous. We'll call this like F. And this part G. So DDS of F times G. Is F prime G plus FG prime. So F is 4S. F prime is 4. G is 6 minus S squared. Here you gotta do it in parts. If you need to, if it helps you until you get comfortable with it, treat 6 minus S as U. So this is G equals U squared. And when you take the derivative, you need the derivative of U with respect to S. Du ds is -1. So this will be G equals T 2U du ds when we take the derivative, G prime. Then plug back in what you had. This is 2 times 6 minus S times -1. Or -2 times 6 minus S. Or if you want, distribute it 2S minus 12. That's probably the easiest way to go about it. You can get the 2S minus 12 without doing a U substitution. But if you saw that you got marked down on the test. Or not doing this step very well on many of the problems that chain rule and product rule, stuff like that. You might wanna do the U substitution until you have it mastered it. So, we're doing this, F prime G. F prime was 4. G was 6 minus S squared. And then we have a plus. F was 4S. Times G prime, and G prime was 2S minus 12. If you didn't clean up the 2S minus 12, yours might look differently, but. We wanna like multiply this out, because we're gonna be setting it equal to 0, and this is not really usable as is. So let's multiply this out. 6 minus S squared is 6 minus S times 6 minus S. It is not 6 squared minus S squared. That is a common mistake I've seen even Calc 3 students doing. Jumping the gun, you actually have to multiply it out. So if I did 6 minus S times 6 minus S. I have 36 minus 6S minus 6S plus S squared. That is 36 minus 12S plus S squared. And if I distribute this, I have 8S squared minus 48S. If I keep going, this is 144. After distributing the 4 to everything. Minus 48S. Plus 4S squared. And we should combine together like terms. 12S squared. Minus 96S. Plus 144 equals 0. That looks like a hell of an equation, but I think all those are divisible by 12. I know this is, and 144 is actually 12 squared. Is 96 divisible by 12?
8.
8, right? I could factor out a 12 here. And we would have s squared minus 8s plus 12 equals 0. And if we divide by 12, that shit goes away, and this problem gets a lot easier. This factors. This is s minus 6 times s minus 2. So s equals 6 or 2. Okay, so we still gotta figure out which one's which. And we need to check endpoints. What are the maximum and minimum values I can have for s here? What?
Did yours say just got?
6 is one of the it is actually. Like. Endpoints, like what? S could be as small as 0. So we're gonna test, we're testing. S equals 2 and s equals 6. And we need to check the endpoints as well. Can s be 12?
Yeah, so
Cause if I do 12, that's the full length, but then I would not have nothing to cut out the other side. It looks like the max s could be would be half the length, which would be 6. Which is actually already one of our candidates. And we're gonna plug them into volume, which was 4s times 6 minus s squared. I think you should be able to see, hopefully by inspection with the 0. If we do s equals 0, b equals 0. And if I do s equals 6, b equals 0 also. And this is a benefit to not expanding out the volume. Like making this one big polynomial, it's easy to see if I plug in 0 here. 0 times anything is 0, right? If I plug in 6 here, 6 minus 6 is 0. 0 times anything is 0. If you expanded this out, plugging in 6 is a hell of a lot more work. But that means something's going on at s. Equals 2. That's for the one we want. B equals 4 times 2 times 6 minus 2 squared. 8 times 4 squared. 8 times 16 is 80 plus 48 is 128. And this was in terms of inches, and volume is a cubic thing. That would maximize the volume. So the max volume comes if we cut 2-inch squares. And with that, let's take a 10-minute break, because we're gonna, next problem's gonna take a while, we might as well give you a break now. Alright, something the two students brought to me in the Mesa Center on Saturday, it was both the same picture. Uh. Memorizing like the shape of the graph, knowing the derivatives. This circle kind of does it. Hopefully you can remember like just knowing slope, the first derivative is slope. And so if it's going up from left to right, it's positive. And if it's going downward if it's negative. But putting this together with the shape of the graph of what the graph part looks like also needs the concavity. And I'll be honest, like in my head when I first saw this, like this is unnecessary. But when I stop and think about it, every time I'm trying to graph this stuff, I'm having to pause and really think about what the graph is gonna look like when I have the two pieces of information. You will have the sine of f prime, and you will have the sine of f double prime. And putting the two together to decide which of these curves you're doing, because these are 4 different curves. One curve like that, one curve like that. One curve doing this, one curve doing this is going off of how these two sines put together. Now, I had made, when we did the lecture on this, I had made 4 different graphs showing them, but this kind of wraps it all up into one. If you put the concavity in the inside, the ones on top are negative, it's a bull downwards. And the ones on bottom are upwards, because it's a bull going upwards. And then if you know the signs of the slope and the concavity, you just pick the graph that goes with it. I don't know if you find that helpful to speed up graphing when you're doing some of the graphing stuff in the previous sections, but. If you do. There you go. Let's go on to back to our regularly scheduled program. You have been
Wait,
asked.
come back. I didn't get the graph.
Josue, slowing shit up.
I went to the restroom.
It's not my problem.
Now it is. Thank you.
I've had Josue for like 2 classes, and when I fuck with him, it's because I've been around him for a while. He is a bond student of mine. Alright, you have been, and he's been a pain in my ass for at least a couple of semesters. You have been asked. To design. A 1-liter can. Shaped like a right circular cylinder. Soup can. That's what it is, well, a soup can that holds a fucking liter would be a lot of soup. But like, that's what a right circular right circular cylinder is, it's a fucking. It's a soup can. What dimensions? Use the least material. This helps minimize costs. But that's not part of this problem. We're not working on the costing, we're just gonna minimize the amount of material needed to make the soup. But like if you're manufacturing fucking stuff that holds shit, you want to save as much money. You may only be saving a penny on every can, but you make a fucking million cans, that's a lot of pennies. You know what I mean? Give you a chance to write that down, then we'll draw a picture. Talk about what we're trying to look for here. That's my sweep can. No, now it's my soup can. There we go.
So an area for all this?
What do you mean?
Or the max area this could hold, or?
Well. Not max area, we're trying to like. We want is like the outside of the can is made with metal, right? The soup can is made of metal. We want to minimize the amount of metal used to hold 1 liter. So we're gonna need a couple things here, we need to know like the volume is 1 liter. But in terms of a cylinder, one of these things. It's the area of the circle times the height. Which would be pi r squared h, if I call this r and this h. And that's gonna equal 1 liter. That's my V. The question is, what's the surface area here? Like how much metal is being used? So like the surface area. We have the 2 circles on top. And bottom. And we have the side of the can.
So we can direct them.
It will be a rectangle, yeah. So the circles, the area of the circle is gonna be pi r squared. But there's 2 of them, so that's 2 pi r squared. The side of the can, if we undid this, you could make it so it looks like a rectangle. Where like this gets curled up. Put together. And then the top and bottom gets sealed on. The height we have, what's the length here? It's the circumference of the circle, right? If we straightened out the circle on the edge, it would give us a circumference. What's the circumference of a circle though? C equals 2 pi r, yeah. So that's gonna be the length of the side of the can, or the area of the side of the can will be 2 pi r times the height.
John, does that just mean that you peeled back both the top and the bottom of the can?
Yeah, if I took the top and bottom off, that's these 2 parts. And then I cut the can like vertically, I could flatten that motherfucker out. And have a rectangle. Now, I'm pretty sure they don't make it that way, they don't like take a rectangle and fold it up, cause then you have like a. A part of the can that doesn't have very good. It's like welded, I don't know. I don't know how, I don't work with candles. I imagine they just make, now I'm kinda curious. I'll have to look this shit up, I'm sure there's a video on it somewhere,
There's a how it's made for sure.
yeah, there's the how it's made videos are really neat. When I watch them, but I'm like, never sit down to watch them. So the total surface area is adding these 2 up. So surface area, I'll call that SA. Is the 2 pi r squared. From the top and bottom, plus the 2 pi r h from the side. And we want to minimize this. I'm not really a big fan of having 2 variables. So we're gonna have to use our equation from volume. To like eliminate a variable. The first thing you do, actually make this a little bit easier, is factor out the 2 pi. And I could factor out an R, but I'm not going to. Cause if I factor out an R, now I have a product rule when I take the derivative, and that's a pain in the ass. Should we replace the H or should we try to replace the R? Let's take a look at both, let's see what our options are. Cause our options are gonna decide like really what's the easiest thing to take the derivative of, right? So we're taking the V equals pi R squared. H equals 1. So if I did H, I could do H equals 1 over pi R squared. And if I did R. I gotta divide by pi H. And then take the square root. Which one of these do you guys wanna deal with? And if you say you want the square root in there, I'm gonna probably tell you get the fuck out. Why make this shit harder? So the H looks like the easier choice, right? It doesn't have a square root sign in. So that's what we're gonna plug in. They both have shade in the denominator, there's no avoiding that. We'll take that in, plug it in, we've got SA equals 2 pi. Times R squared. Plus R times. 1 over pi R squared. Which will give us 2 pi R times R squared. This is like R over 1. This will be 1 over pi. I'm gonna have a 1 over R, but I'm gonna write that as R to the negative 1. Cause if I write it as R to the negative 1, I don't have to do a quotient rule. That's my SA. So the variable here is R, derivative with respect to R. So DSA dr equals, I've got the 2 pi. You not need to do a product rule with coefficients. This is 2R. And then I got 1 over pi. I bring the power down and I lower the power by 1. And I'm gonna distribute that 2 pi. This will be 4 pi R. Plus, the pi will cancel out on this one, no, not plus, minus. Minus 2R to the negative 2. And that's not as helpful as seeing it. As R squared on top. And we're doing maximizing, minimizing, we set the first derivative to 0. Now, I don't like having that fraction there, can I clear fractions? And if so, why can I clear it? We could get a common denominator. We can clear the fraction here though. By multiplying by R squared, but there's a particular reason why. You can only do it if you know that it doesn't equal 0. First off, I know it doesn't equal 0 because it's on bottom. And second off, how much volume does a can of radius 0 hold? No, It doesn't have a radius, it's not a fucking can. So we know it's not gonna equal 0. R doesn't equal 0, so I can multiply both sides by r squared. And I get 4 pi r cubed. Minus 2 equals 0. God, that's ugly. Well, nothing to do but solve for it. If I add the 2 over and divide by 4 pi, I get 2 over 4 pi. Which is 1 over 2 pi. And then I gotta take the cube root of it. So this will equal r. And this is an exact value. But is that helpful at all? Not really. But on a test, you better show the exact value. So show the exact value, but then to use it, let's make it a practical value by finding out what that value is.
The approximation.
Yeah.
No, 1.16.
Make sure I get the same thing. I'm not questioning you, but we all fuck up sometimes. I do it all the time. I make a habit of it. I got 0.54, which means one of us fucked up.
Are we in radians or degrees?
Pi is not in either,
Oh, okay, so what I did, never mind, I got it,
like radians or degrees should get you the same answer.
0.54?
Yeah.
Check.
So to a couple decimal places, I'm getting 0.54. Units. I don't actually have a units listed here, do I? Some particular unit has to be it, though. We need to find the units in terms of. Liter, like what is. The liters is metric. So. It can't be 0.54 meters, that's a giant fucking can. Right?
Ounces?
I don't know, we'll circle back to that. I think 1 liter is like 1,000 centimeters cubed, I think centimeters would be really fucking small. But a meter. Is almost like 3 feet, so like half a meter is 1.5 feet. A fucking radius of 1.5 feet is making a big ass fucking circle. I don't know what the fucking units are here. We'll have to explore that later. But. They're related to whatever liter is, I think liter is metric. Fucking, I wish the world was all on one system, this shit would make shit easier. Then we need to find h. So what would h be? H equals 1 over pi r squared. So I'll square that. And multiply it by pi. Then I'll do 1 divided by that. And I'm getting approximately 1.08. Units. We could check the endpoints. But the endpoints are gonna be stuff that minimizes volume. Endpoints will make the volume 0. And we don't want that. Like having an R equals 0 and RB like some sort of maximum doesn't work here. So those are the two things we're looking for. I wonder what I had before. I've done this problem in class before. What did I put? I'm now kind of curious. The hell did I do? Did we just gloss over that? I'm looking real quick. Oh, I actually converted to centimeters. Which is probably the good choice. But you have to could change it, alright, so what we should have done. This is how you find out you fucked up, you get down to the bottom, you're like, I don't know what the hell the answer is. What we should have done is said, and we're not gonna redo the problem. Cause I'll just take a while. These are unhelpful units. Back to the drawing board. One liter is 1,000 cubic centimeters. And that was pi r squared h. So we should use h equals 1,000 over pi r squared, and that would be in terms of centimeters. Now notice that's gonna change the values of this shit a lot. Is it? That just puts 1,000 times here.
You mean our R would be different then?
Yeah, our R is gonna end up being different. So how does that change our stuff? SA would have been 2 pi times r squared plus 1,000 over pi's r to the -1.
I don't know if this helps, but 1 liter is equal to 1 cubic decimeter, which is 1/10 of a meter. So technically our answer would be in decimeters, I think.
Might be. Let's see, what was the actual value on the one? Yeah. I'm getting R equals 5.42 centimeters. But a centimeter to a decimeter would shift the decimal over 1. These should be in decimeters, although how useful that is. But. It's going to be decimeters. But if you don't know it, you can work from this and go there. And you will end up getting R, if you go from here, R equals 5.42 centimeters. And this kind of just shifts the needle on the H. H is having another decimal place, 10.84 centimeters. And now that sentence seems like a fucking soup can. For a liter, it's a big soup can. Not really. Well, radius, like. What's it, like about 2.54 centimeters is an inch. So this is like a radius of about 2 inches, which means a 4-inch diameter, which is
Not terrible,
not terrible. It's definitely bigger than a regular soup can, but not like,
probably like a medium sized soup can.
yeah. But 10 centimeters tall, or well. That's about 4 inches tall.
You ever get those, like those things of fruit cocktail that come in a
Yeah.
can? I'd say it's probably about, like, right about that. Cause
I
it's always a
think
little,
feel right though, cause like a 2 liter bottle is so fucking big. Right? But then again, the bottom is completely like bumped and so it like elevates the size of a 2 liter bottle. And it is 2 liters, so I'd have to cut it in half, and the top is always like empty space, I guess.
You know, I mean, for soda, if we're talking about like soda, like a liter, 2 liters, they make it tall on purpose to stack as many as they can vertically together,
Right.
so it's a lot thinner.
That's another factor they have to consider is
yeah,
minimizing space that it takes up.
and probably the thickness of the bottle too, it's not like. Not like that thin, it's gonna be a little bit thicker, so there's how much we hold.
Yeah, we didn't address thickness. Alright, let's do another one. Youth group. Screen so I can see it. Is planning, I got this from someone else and I've never heard of this event. I don't know if you have, a youth group is planning their annual rain gutter regatta. This sounds totally made up to me. Why the fuck a youth group would do this, I don't know. So what they do is they take a piece of sheet metal. That is 3 meters long. And 30 centimeters wide. And bend. Up the. Narrow side, the 30 centimeter side. In thirds. To make a rain gutter.
Oh, I know, it's a,
Making the angle theta. Have you heard of this? This is a real
yeah,
thing?
but it's not a youth group thing, it's a Boy Scout thing. So,
Well, that was definitely a youth group.
oh, I mean, I'm sorry, I'm thinking youth group as in like the religious youth group
Oh,
thing,
yeah.
or thing, that's what I'm thinking.
But
But no, I've seen Boy Scouts, cause I work at a hotel, like Boy Scouts do that, they brought that in with them,
really,
and they race boats on it.
like, I know the Pinewood Derby, I was Boy Scout, but we never did no fucking rain gutter. Boat making thing, that's, okay. So, what angle? Should they fold the sheet metal at? To maximize volume?
I don't know, John, just have them folded up, and they'll be good.
Right,
It's modern of the day.
if I was in charge, if I was like the troop leader, we'd be fucking maximizing. If, I don't know how maximizing the volume would help, but if that did. Oh, I'm all about optimizing. So let's see, it's. 3 meters is a lot longer than 30 centimeters. 3 meters is 300 centimeters. Maybe we should get everything in the same units. And what they're gonna do. Is then they take this shit and fold it in thirds. And I'm gonna make a side profile here. Where this is folded up in angle theta. On each side. And if it's in thirds, what's the length of each of those pieces? Each of these is 10 centimeters, right? And we wanna maximize the volume, which means it's doing some shit like this. So maximizing the volume is gonna be. The volume is gonna be the area at the end. Times the length. So what would be the area at the end? Let's make a bigger picture. So this is 10 centimeters. This is 10 centimeters, this is 10 centimeters. That makes this portion here 10 centimeters. I don't know how tall it is, it's H. And I don't know what this length is, let's call that X. This problem is a little bit easier if I make one observation. It's not a lot easier, but I'll make the number smaller. Is the length a factor in determining it is a factor in determining the volume. But will it affect the maximizing thing? Cause the length here is fixed. I could write this as volume over L equals area. And L is a constant.
You know, it's 3 meters.
Yeah, so we know it's 2 meters. So if I max this. I'm maxing this. And the 1 over L does not change the max. I mean, it affects the overall volume, but it doesn't affect the overall process, because it's a constant. So we could just maximize the area. But if you don't see that, well, we can do the full volume thing. So we need this area thing here. I know this rectangle is H times 10, right? Area of this thing is 10H. This is making an angle theta though, and that's what we're having to look at. So our equation needs a theta in it. It turns out if that's theta, this is theta as well. And each of these rectangles, or not rectangles, the triangles. If I just look at one of the triangles and I put it where it's like this. The flat side is the X, the tall side is the H, and the diagonal is 10 centimeters. We have 2 of these. Plus 10H. So the area of the triangle is 1/2 base times height. Which is 1/2 X times H. But there's two of them, so it's just gonna be, two area is just XH. And to that, we're adding 10H from the rectangle, so these are our triangles. These are our this is our rectangle. But none of those have angles in them, and that's what we're needing to focus on. So we need to rewrite that in terms of angles. This might be a little bit easier if we factor out the H and make it H times X plus 10. We're gonna have a product either way we do it. But here we'll maybe have less, I don't know, less derivatives to take. So, and in our picture, the angle is between the X and the 10, so this is our theta right here. That's theta. So let's see, sine of theta would be opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Which means H equals 10 sine theta. And X equals 10 cosine theta. So my area of the H times X plus 10 is 10 sine theta times 10 cosine theta plus 10. I could factor out a 10 here. And make this 100 sine theta and just make this cosine theta plus 1. And the volume would be that times 300 for the length. And this is in centimeters cubed. If that's the length. And this is the area. This problem's not that fun, is it? You're like, eh. Alright, we're down to theta, so we need dV d theta. I'm gonna factor that, pull the 30,000 out, and we will do d theta on sine theta times cosine theta plus 1. Which is a product rule. So if I label this F and G, I need F prime G plus FG prime. F prime is cosine theta. And G stays as cosine theta plus 1. And F is sine theta. And G prime is negative sine theta. I have cosine squared theta plus cosine theta minus sine squared theta. I don't like having cosines and sines here, so. Let's see, cosine squared plus sine squared equals 1. So if I subtract the 1 over here. And subtract negative sines or sine squared over there. It looks like negative sine squared. I can replace this with cosine squared theta minus 1. If I do that, I got dv d theta. 30,000 cubic centimeters. Times, now I've got 2 cosine squared theta. Plus cosine theta minus 1. And that's what I'm gonna set equal to 0. If it helps you, make a U substitution here. And this factors, I'm not sure how, let's see. I need a -1 and a +1, and I need the 2u to be the positive term when I add them together. I think that's it. Let me just quickly multiply it back out. 2u squared plus 2u minus u minus 1 will get me 2u squared plus u minus 1. Yeah, that's right. So we can divide by the 30,000, which meant the 300 didn't play a factor at all, right? So we actually never did need the 30 or the 300 centimeters in there. We divide 30,000. And I get 2u minus 1, which is 2 cosine theta minus 1. Times cosine theta plus 1 equals 0. You set each of these equal to 0. And I get cosine theta equals 1/2. Or cosine theta equals -1. So what does theta have to be to get cosine of 1/2? In radians, let's do radians. Pi over 3, yeah. That's 60 degrees, pi over 3. What, there's also another one. We could do negative pi over 3, but can we fold this negatively? The other option is going all the way around the circle and getting 5 pi over 3. But can I realistically fold this 5 pi over 3? No. So like, you could, I'm gonna list them as options, but can't fold like this. The best we're gonna be able to get out of a fold is a full pi, right? Cause then it's hitting its own metal and it can't go through its metal again. Right? It'd be like making it completely flat. So endpoints on theta would be 0 or pi. Like you don't fold it, or you fold it completely. Yeah. So that's don't fold. And that's a complete fold. Like. All the way in, and now we have no volume. Both of these end in no volume. If it's flat piece of metal, it doesn't hold anything, and if it's completely folded where it's. Again, flat, there's no volume. What is the cosine theta equals -1? What theta does this result in?
2.
Are you really gonna answer with 2 pi/2? I'm gonna write that down for you, just so you can see what you said. Isn't that just pi?
Oh, right, okay, yeah, I see.
This is where I wish I had my really stamp with me in class. Yeah, it's just pi. 2 pi/2 is valid, but. Very awkward way of saying it. We already had it though, that was there. So it looks like. Theta equals pi/3 is the fold we're looking for. Does it maximize the volume? I don't even talk, no. It sounds like it should, but maybe let's do a sign chart. And we're plugging it into, the 30,000 doesn't matter, so let's plug it into 2 cosine squared theta. Plus cosine theta -1, and let's do test points. Or here, or plug in here. We wanna test it, below it would be pi/6. And above it, pi/2 makes this an easy calculation. Oh, fuck it, let's go to 0, that's even easier. 0 and pi/2 are the easiest calculations there, right? Cosine of 0 is 1. So I've got 2 plus 1 minus 1 is 1, which means it's positive here. And if I plug in pi/2, cosine of pi/2 is 0. 0 minus plus 0 minus 1 is -1, it's negative here. This was sloped, so it's going up and then down. That is indeed a max. So the volume is maximized there. Maybe you have to do some trig that you probably haven't had to do in a while. That's a good problem. Do they really fold up metal? Like, why would they, who cares about the volume?
No, I don't think they do, like this is,
That's just contrived to, like,
it's just like a question, I guess, but
Probably
no,
just the amount of water the gutter would hold when they race the boats.
to me, I would wanna minimize the water. That way it's not as heavy,
Well, no, but it's like whatever, oh, yeah.
but it still needs the whole fucking water. So I don't wanna make
Probably
it
depending on
flat.
how much, what size the kids make the boats.
Right.
Like,
Boats, yeah, the boat still needs to fit in it. So like the width of the boat is what matters, but. Still a good practice problem. Alright, that's all I got for you. We could do another, but we don't have time. We've only got like 4 or 5 minutes left, so. GTFO. Have a good day.
Have a good day.